Okay, I think seems like nobody is about to join. So let's get started. Good evening, everyone. Welcome to the class 9 tutorial class 9 of this problem solving through C programming NPTEL course. So previously we have seen about you know different kinds of data structures, in the sense we try to understand what integer variable is, what is float variable is, and what is how do we use arrays, and how do we traverse in the array, and how do we find a particular element, and we have tried to understand what is the use case of that thing. So basically we have covered most of the data structures part. So we learned about data, but in today's class we will try to learn more about the algorithms. So how do we there are so many algorithms and there are so many methods that are there, but we will try to look into some fundamental algorithms. So like some techniques, like, so this is a altogether a different subject. So this is called as data structures and algorithms, but it has some correlation with C. So that's why I think professor has introduced this particular class in this series of lectures. So we will try to understand how do we basically do the searching operation. So we will try to understand what is the difference between linear search and binary search, and what is the issues with the linear search, and why we need to use the binary search, and we will try to look into some fundamentals. So although these are not very up to date or modern sorting techniques, but these are very preliminary sorting techniques. Like we will look into the bubble sort, insertion sort, and selection sort. So then we will try to understand we will try to solve some quiz question, and then we will try to wrap this session. So let's get started. Let me switch back to my entire screen sharing. So I hope you are able to see my screen, right? Okay, cool. So first we will try to understand, before actually jumping into these searches and sorting techniques, we will try to understand what is macros. So there are different kinds of macros, but we will try to understand what macro is at the first. So macro in C programming language is a specific, so these are called as pre-processive directives. So that means before the compilation starts, we are telling the compiler that this is a heads up. So you can declare some variables, and you can define some functions in this pre-processive directives. So whenever we write the C source code. So whenever you write the macros or pre-processed directives, so that pre-processed directives will be included in the compiler, and then the compiler will take that code, and then it will be converted as an object code and given to linker, and then it will be converted to the executable code towards the end. So we use hash define for this pre-processed directives, I mean macros. So basically we have seen that we use hash include stdio.h. So that is like we are including the header files of some other locations, but this hash define means we are here the programmer is explicitly telling that okay, you need to process some things before you start compiling. So that will be included before the compilation process. So basically there are you can use macros in two different ways. So first is object like macros. So in this object like macros we have already seen various examples in the previous class as well. So we will define the variable kind of things which can be used later in the program. So simply macros, so this object like macros are simply macros that can replace with certain values. So if you want to replace certain values in other place of your code, you use this object like macros. So let's say for pi, if you want to use pi as 3.14 wherever you use pi pi variable or pi symbol, then you can define that. Okay, let's say I'm defining hash define pi space 3.14. That means wherever pi is used in the program, in the subsequent program, so that value, that at that place 3.14 will be replaced during the compilation time or runtime. So that is about object like macros, and that we have seen already. So the second case is like function like macros. So this is not we have seen in the previous classes. So in this function like macros, just like object like macros, we can define a function. So let's say if you try to define area, so area is a function which will take an argument r, which is a radius. So we are defining a function here, and we are writing the implementation of the function here in the parenthesis. So this kind of function like macros will be used in the program. So there is no type checking, and you can pass different types of different data types in the same macros. So there are various uses for this macros, and which are detailed in this link. So you can go more deep into that thing. I just want to tell you guys that there are two kinds of macros, and we will try to look into some sample program by using these two variations of macros. So let me open my console. So here I have defined object like macro, like pi equal pi as 3.14, and similarly I have defined function like macro also. So I am using this object like macro in here, function like macro. So then I am passing a variable, argument as radius to this particular function, and that will be used. So basically I am trying to calculate pi r square. So those r value I am reading it from the user or dynamically, then I am passing it to this particular function like macro. So it is it is very straightforward program. So we just define the radius, and you can see I have defined radius as 2.5 here. So then I'm passing the radius to this particular area macro, and then I'm assigning a variable area, and I'm calling a macro, and I'm passing this 2.5 to here, and then I'm printing the outputs. So let's try to run this program. So clang mac. So you can see that okay. So you can see that, see, I am using I have defined a function like macro, and which will accept radius r. So we have not defined any data type for this variable. So you can see here I have declared a float value, and I call this particular function macro, and pass this float argument. Whereas if you come down, so I have used integer value, and then also I call this thing. So you can pass different kinds of data types to the macro, and you can perform the task. So that is the high level use case. Maybe if you are writing some program, so you just need to remember that, okay, I can use macros which can accept different kinds of data types, and which can be included as a pre-processed directives towards the compilation. So this is the typical program to showcase that how the macros will be used. So that is all about macros. Then we will come back to the slides and look into it. So I think I have just try to scratch the surface of the macros, you just need to dig more into it by using this link, or you can Google it. So, but the use case I want to show you is that particular thing. So, now we will look into the searching part. So, in this search part I will try to explain two kinds of searches. First one is linear search and the second one is binary search. So, linear search is very fundamental search that we have tried in the previous classes as well. So, let us say if you have a series of n elements, and what we are trying to do here is this algorithm will try to look a particular element. It will go index by index and it will try to search in each index and until it finds a specific until it matches a specific value, and then whenever it finds a specific value, then it returns the value. Otherwise, after completing all these things, it will say that okay, we don't have any we don't have this particular element in the array, and it will exit. So, there are two kinds of linear searches are there. One is ordered linear search and unordered linear search. So, ordered linear search means if you are trying to perform linear search on sorted elements, so that is called as ordered linear search. So, if you are trying to perform the linear search on elements array like this, so this is unsorted array. So, if you are trying to perform search on such a kind of arrays, that is called as unordered linear search. But in both the cases, the time complexity is same. So, the time complexity and space complexity is called as, and I mean both these things are called as asymptotic notations, and this is very much detailed in the data structures and algorithms class. But how do we calculate time complexity and the space complexity? For especially for time complexity, there are some theorems called Master's theorem, or some other theorems is also there. So, by using those theorems, we will calculate the time complexity. That means how much time it will take to execute that particular algorithm. So, that is called as time complexity. Whereas space complexity means the how much space that this particular algorithm will take. So, let us say if you want to store some how much amount of data it is required to perform this operation. So, that is measured in terms of space complexity. So, that is out of scope for this class, but I just want to give you a heads up that what is this time complexity and space complexity. For the time being, you can understand that. Okay. So, data structure is like you have data represented, right? So, let us say array is a data structure, and if you try to use linked list, so there will be linked list means array integer plus a pointer combined together. So, that is called as linked list. And if you have hash map, that is another data structure. So, how do you represent the data? So, there are different forms of representing data. So, those are called as data structures. So, array is a data structure, hash map is a data structure, linked list is a data structure. So, how you represent the data matters. So, data giving a structure to the data. So, this will be organized in this way. You can see that array is like a one dimensional. So, it will be one after another. So, that is the data structure. So, if you see the linked list, so integer with a pointer, so clubbed together is called as linked list. No, data type is different. So, data type is you are saying that what kind of data types are like how the compiler will store the data. So, let us say if you give integer a equal to 5 means the 5 will be stored and it will be given this much of memory in the space, and that is called as data types. So, because you are telling the compiler that okay, let us see I'm using a value which needs this much amount of space and which should be like looking like this. So, if you define a float variable, so after decimal point, so you have these many points, so it will allow such certain points. So, if you want to represent a very long value, so you need to use the double value. So, like that, so that will be more dependent on size and how you are telling the compiler to store the value. So, data structure means the organization of such a data. So, there will be a specific form in which you use and you represent the data to perform a specific task. Okay, so that is called as data structure. So there are subtle difference between that. You try to dig more into it, so try to Google it and you can search it. So there is a fundamental difference. So this is all about linear search. The time complexity in the worst case, so the big O represents the worst case scenario. There is best case, average case and worst case. So mostly we will try to measure the time complexity in the worst case. So let's say in this case the time worst case will be n, because the element which you are trying to search will, if it is in the last index, so you need to go through all the elements, so you need to visit n elements, so that's why the time complexity will be n. So but you need to understand about Master's theorem to calculate the time complexity for various algorithms. For the time being, you just try to remember that there is a three types of time complexity notations, and we are using the big O notation which represents the worst case. So the time complexity in both ordered and unordered linear search will be big O of n. So we will try to execute this linear search. So we have seen already this program. So we have just a sample array, and we are finding the size, and we are just calling the search, and we are giving a integer. So we are giving the number which you want to search, and that will be here, and n is the size of the array. And the code will be very simple. For y equal to 1 to n, we are trying to see whether a particular element is matching with the element that we are trying to search, and if it found that particular element, then we will return that particular index, and that index will be printed. So that is all about linear search. So this is straightforward. So let me try to compile the program. clang linear one more. So element is there in index 3, 0, 1, 2, 3. So that is how linear search will be working. Now we will look into the another important search. So that is called as binary search. So the binary search is fundamentally different from the linear search, because we don't need to do all these comparisons in the binary search. So binary search algorithm for finding an element is by using a special technique called if somebody knows this data structures, if somebody has studied this data structure, they might know there is a special way of algorithms called divide and conquer. So by using that divide and conquer, binary search will work. So binary search can be implemented only on the sorted list, so it is not going to be performed on unsorted array. So we before performing any search, the array should be in the sorted form. So that is called as binary search. So now we will try to understand how this binary search works in practice. So let us look into this example. Let's say we have all this array, and you can see that these elements are in sorted order. So that means this is sorted, and this is in the ascending order. So we want to find an element 23. So previously in the linear search we are going index by index, but in this case the approach is different. So first how the binary search will perform is like, it will try to consider low value as a first index as a low value, and the highest index as a high value, and it will try to find out the middle value. So if the middle value is like low plus high by 2, so 0 plus 9 by 2, that is equal to 4, and it will try to see. So if the middle element is matching with the searching element, so then it will return that particular value. So if it is not matching, it will check whether the middle element is bigger than the element that we are searching. So if it is bigger than this particular middle element, the element that we are searching is bigger than this middle element. So, it will ignore this first half and it will only search from this middle plus 1 to remaining right half. That means whatever is there in this right half of this particular middle element. So, the low value will become here and the high value will become 9, and again the same algorithm will work. So, again it will try to find middle element by using the same formula, low plus high by 2. So, 5 plus 9, so it is equal to 14, 14 by 2 equal to 7. So, middle is 7. So, this time the value which we are Sumit, you have any question? Okay. Okay, cool. So, it will use the same algorithm. So, it will take the low value and high value. So, low plus high by 2, which is equal to 7. So, in our case we are searching for 23 and 23 is less than this middle element. So, it will ignore this particular part and it will only consider these 3 values. So, low plus, so in this case the low value will be 5 and the high value will be 6 because it is less than this value. So, the search need to be performed only on this value. So, low is 5 and high is 6. So, 5 plus 6 which is 11, 11 by 2 equal to 5. So, that is 5. So, it will try to see whether this particular value is matching with 23. So, in our case it is matching. So, it will return this particular value. So, the complexity, so you can see earlier we used to do lot of comparisons, but here, so if we have this array and we are finding the middle element. So, if it is there in this particular if the element which we are searching is greater than this middle element. So, we are considering only this part of the program and again we are doing the search. Again if it is middle element is greater than what we are searching for, we are, so the complexity of doing the search is drastically reduced. So, you can see because of this the time complexity of this algorithm is just log n, not the, in the worst case also it is log n, and in the best case it might be log 1 because the moment you find the first mid the value is equal to the element which you are searching. So, it will be 1. So, this is all about binary search. So, it will be working on divide and conquer approach, and that is why the we do not need to search each and every index. So, we are trying to reduce the search space. So, that is the key element of this binary search. So, you can see the algorithm. So, let us say if we are passing an array and element which we need to find and low and high. So, if low is high, this is just a validation check. So, otherwise, so we are finding the middle element. So, if the value which we are searching is middle element, then just we are returning that value. Otherwise, we are performing the same search if the value which we are trying to look is greater than the middle element. So, we are trying to cover the we are trying to call the same function recursively by changing the low and high values. So, here the low value will be mid plus 1. So, that means we are searching this space mid plus 1 and high value will be same. Otherwise, if in this case the mid value the value which we are trying to search is less than the mid, we are trying to perform the search on low value will be same and mid plus 1 will be search. So, that means we are trying to reduce the space. So, we are by using this recursive calling we can able to find out the element, whether the element is there in the array or not. So, the complexity is log n because we do not need to search n. So, every time we are trying to let us say, let us consider this example Arshad. So, we have 9 elements. So, earlier we have to do n searches. So, time complexity is n, so 9. So in the worst case, because if the element is there in this 9th value, but however in our case, so we don't need to do that many searches, even though it is there in the last value. So what is the log 9 value? What is the value of log 9, Arshad? So we just need to do one search here, and again we need to do search on this space, and again you need to do, and here you can find the element right away in the 3 or 4th step. So we are trying to, in the 3rd step only we are trying to find out whether the element is there or not. So that's why the time complexity is less. So how they deduced it to log n is different. So you need to understand about Master's theorem for that, but fundamental thing is the time complexity is very less than linear search, because we don't need to explore the entire search space. Okay. So let's try to run this program to understand. So same program that I have written, just the change. So we are finding the mid element. If the mid element is there, then we are trying to return that value. Otherwise, we are calling recursively. If the element is greater than the mid element, then we are trying to change the low value to mid plus 1, and we are mid plus 1 to the last element. And if the value which we are searching is less than the mid value, so we are trying to confine our search to only the left portion of the mid value. So that's my lower value will be same, and we are trying to search till mid minus 1. So the logic will be same. We are just, all these programs you just need to keep you just need to understand that we are passing array as an argument here, and low and low value, high value, and the search element which we are trying to look into this particular space. So let's say C line. So although you can think that if you are trying to use your compiler, you may not see the subtle difference between linear search and binary search, because we are just using a toy example. Let's say 5 or 6 example, 5 or 6 values. Let's say if it is 1 lakh, then you can definitely see the variation in terms of execution, because the time complexity and the search space is reduced drastically. So you can see the difference. You try to do this thing. So let's say if you have 1 lakh values in the same array, and you try to perform the same search by using linear search and binary search on the 2 parallel threads. So you can see that binary search thread will complete the execution first, and it will return. So here there is not much difference, but for a large search space you can see the difference. So this is all about linear search and binary search, but in order to do the binary search, we want the elements to be in the sorted order. So first we need to understand how we can do this in real time. So that means how we can sort. So let's say if you have an unordered array, then how we can sort those arrays. So there are very classical different kinds of sorting algorithms are there. We will try to look into some basic sorting algorithms, in which the first sorting algorithm is called bubble sort. So sorting algorithm fundamental task is to rearrange the array values according to the order by using some comparison operations, and new order will give new array will give the sorted order. So that's what the high level intuition. So bubble sort is fundamentally very simple. So in the first thing we have this array, there are different passes. So there are different passes are there. So let's say if you have a n element, so there will be n minus 1 passes. So in each pass what happens is that it will take 2 elements and it will compare. So and based on these two elements it will swap. So whichever is big it will try to swap. So let us say 0 3 3 is bigger, so 3 will swap, 1 3 1 is bigger, so 1 will be swapped. So let us start from the example. In it will be starting with 6 3, 6 will be swapped, and 0 6 6 6 will be swapped. So all after passing through all the passes, so the highest element will be went to the last element of the array. Then in the second pass it will find out the, by doing this recursive swapping, what it will try to do is it will try to bring the largest element towards the left, towards the right side, or that means towards the end of the array. So in the first pass it will, if you can clearly observe, the 6 will be gone to the last index by doing various comparisons. In the second pass the 5 will be given to the subsequent index, second highest. In the third pass it will, 3 will be getting here. In the fourth pass the 1 will be coming here. So for clear example I will try to illustrate with this example. Let us say if you have an array 5 1 4 2 8. So in the first pass, so let us say if you have 1 2 3 4 5, so that means there will be 4 passes. So in the first pass what it will try to do is it will compare to these first two values. So 5 1, so because 1 is 5 is greater than 1, so the 5 value will be swapped. So that means 1 5, remaining elements will be same, 2 4 8. So this is first comparison. Then in 1 the 1 will be ignored and the 2 3 will be compared. So subsequent elements will be compared. So 5 4, in the 5 4 5 is bigger, so 5 will be swapped. So 1 4 5, and in the third swap, so 1 4, this time the comparison will happen between 2 5, 5 2, so 5 is bigger, so that is why the swapping will happen 2 5. Then the finally in between 5 8, 8 is bigger than 5, so there will be no swap. This is first pass. Again in the second pass, again it will start from the so it will start from the first. You need to observe one thing here. So by end of the first pass the highest element of this array will be there in the last index. If you come to the second pass, the same thing will happen, 1 4 will be compared, and because 1 is less than 4 there is no operation. Then 4 2 will be compared and it will be swapped, and in the third iteration, so 4 5 will be compared, and because there is no change, because there is 4 is less than 5, and finally the 5 8 will be compared and there is no change. So by this time we almost have sorted array, but this algorithm is not that intelligent enough, because it has n minus 1 passes. It will do remaining all 3 4 passes as well on the sorted array, and which will cause the time or execution time or CPU cycles of CPU cycles, because we are doing the unnecessary comparisons on the CPU cores, even though the element is sorted. So that is why it is not that much effective, and you can see that for every time you need to do n minus n times comparisons with n time comparisons. So that is why the complexity will be n square for this particular. In the worst case the time complexity will be n square, big O of n square. So there is some link given, there is some discussion in Quora about what is the number of passes that need to be there. I just suggest you to go through this particular link and verify. So we will try to understand this bubble sort here. So this algorithm is quite simple. I will start from the driver program. So driver program in the sense wherever you write the logic, so the program initiation will happen here. That is why this is called as the driver section of the program. So we have an array and we are finding the excuse me, we are finding the we are trying to sort this particular array. So n will be the size of array, size of this particular array, and we are calling this bubble sort by passing array and the number of values in that particular array. So this particular function is nothing, it will just print the array. So we just use this function to print the values in the array. So what we are trying to do here is for I equal to 0 to n minus 1, 0 to n minus 1 and j equal to 0 to n minus I minus 1. So, let us say if you have 5, you are trying to compare between till 4 to 5 we are comparing, right. So, that is why we have n minus I minus 1. Also then every time we are doing the comparison operator, just I have explained as I explained in the in the previous slides. So, we are just trying to compare, and if the value is j is greater than j plus 1, then we are trying to swap. So, otherwise we are just ignoring. So, whenever the swap function is called, so there we are using the pointers, so that that particular value will be replaced. So, we are just swapping two values. So, that means, how can I explain? So, this is here. So, just 1 4 5. So, just if you want to swap these two values, we will just call this particular function. So, the 4 5 will be there. So, indexes values in the indexes will be swapped, that is it. So, this is all about implementation of bubble sort. So, which is quite easy to do, but which is not an effective algorithm. Big O of n square, that means lot of time comparisons, and you can see that from an example, even though the array is fully sorted, it has no intelligence. So, it will do the comparisons and waste the CPU cycles. So, this is about bubble sort. So, we have passed 64, 35 and all these things. Finally, you can get the sorted array. If anybody is using Python kind of thing, so all these bubble sort, insertion sort, selection sort, all these sorts are implemented with a predefined functions in the Python as well. So, you can, if anybody knows Python, they can directly use it when they are writing. So, you do not need to write this code again and again. So, but because you are a beginners and learning the C programming language, so that is why I have written the logic to make sure you will understand the concept. So, this is all about bubble sort. So, now we will look into the insertion sort. So, insertion sort is very typical. So, you can see this thing in many places. Let us say if anybody know how to play the cards. So, let us say you have random cards on rummy table. Let us say you take those cards. So, you do not know what card you might get in the next iteration. So, first let us say if you pick up one card, you got 5, then if you pick up another card, you got 9. So, you will be keeping that card just adjacent to 5, because this is the best possible arrangement. So, then you pick up the another card, which if it is a 1, then we are trying to put the 1 before 5, because the 5 is less than 1 is less than 5. So, like that. So, it is just like it is very similar to this algorithm is very similar to how you sort the playing cards in your hands. The thing is, let us say I will try to demonstrate this with this particular example. Let me try to finish that GIF. So, we have all these elements. So, first it will be sorted, and second it will come here, and so it will see where in what position that particular value will be inserted, and we are just shifting the position of the subsequent elements, and we are keeping inserting that point here. So, that is the high level idea. So, if you try to understand the algorithm, iterate from array 1 to array n. So, first value to nth value, compare the current element. The key means which you are searching. The key value will be, in the first case, key value will be 5 with the predecessor, that means the previous one. So, if it is less than that particular one, move that particular one to right side and keep this one inserted here. So, if it is, let us say if you have more values, let us say if you have 3 values. So, yeah, see 2 is 6 is 9 is 7 is shifting 2 places, because it has to compare the values till it reaches the particular position where it is greater than the predecessor element. So, it will do the comparisons, and then whenever it feels that the predecessor element is bigger than the element which key element, then it will stop and insert in this particular position. So the algorithm is quite simpler. The compare the element to its predecessor. If the element is smaller than the predecessor, compare it to the elements before. So if the element is smaller than the predecessor, you try to compare it with the before element. Move the greater elements on position up to make space for the new element. So I think you will get to see this with this particular example. Let's say you have this particular array. So first 4 will be there, so you don't have any issues. Then you pick up the second card 3. So 3 is there, and you have 4 in your left hand, and you have 3. So where you need to keep the card 3 in order to keep it in the ascending value. So you have to keep the value before the 4. So you just need to move the 4 to one element, one position right side, and insert that particular 3 here. And similarly, then 3 4 are there. So you take the third element on a fly, and you try to do the same thing. So if it is less than this particular predecessor element, okay, move one position, and again you compare this with this element, and it is again less than this value. So you need to shift 2 positions of these 2 values to the right side and move this value here. And similarly in the 10, so 10, if you try to compare, the 10 is greater than, 10 is not less than 4 3 2. So you don't need to perform any operation here, because you don't need to move or swap here. Similarly the case is for 12. 12 is greater than 10 and greater than 4 and 3 and 2. So you don't need to. Again, if you see the 1, the next element, so it is less than 12, okay, then it will come here. So again it will compare with 10, it is less than this one, again it will compare with here, it will compare with 3, it will compare with 2, okay, then it is less than this 2, okay. That means you need to shift all these element one position right side and then insert the element in the first position. So similarly, if you take the 5, it is less than 12, so it will do the comparison, it will come here. Again it will compare with 10 and it is less than 5, and it will come here as 5. So again it will compare with 4, 4 is less than 5, that means then it should not go further down here. So the 10 and 12 will be shifted to shifted one position right side, and the 5 will be inserted there. So this is the high level algorithm for insertion sort. So here also the time complexity is big O of n square, because let's say if you have an element which is there in last, let's say if the one value is there in last, you need to do all the comparisons twice and you need to shift the elements again. That's why this is also not an effective algorithm. In the worst case, you have time complexity big O of n square. So the logic is similar. So we have an array, we pass we have size of an array and we pass the insertion sort. So insertion sort is here simple. So initially it will iterate from 1 to n, I equal to 1, I less than n. So initially we are taking key value as 1, that means the first position as key value, and j value is I minus 1. So what we are trying to do is, I will try to explain whatever the logic I have written here while loop. So it will check whether the j is greater than 0, move the elements from 0 to 1. Whenever we are comparing, if the element is less than this particular one, you just need to move this particular thing to one place right side. So for that one we are trying to, let's say I will take an example here. So initially I value will be 1, so I value will be 1 and j value is equal to I minus 1, that is equal to 5. So we are trying to move this value. So j greater than 0, j greater than or equal to 0, and array of j is greater than key. So array of j means array of j is 5 is greater than key. So then this one is greater than this one, so we need to move this one here. So what we are trying to do is, we are trying to shift one position of all these elements. So j, we are trying to shift the value of j to one place right side. So ar of j plus 1 equal to ar of j. So in this j plus 1 value we are assigning the j value, that means the 5 will be coming here. If you try to see the next iteration, the value will be we don't have anything in the 0th position. In the first position we have 5 and the second position we have 2 and second position we don't have anything right now, and we are trying to, by using this statement we are trying to j plus 1. So, after doing this one we are reducing the j value again to the first value, and we are assigning that particular key value to the j. So, we are just keeping this, moving this 4 here by using this ARR of j plus 1 equal to key. So, same logic what I have written there, I tried to convert into the programming format. So, you just need to sit down for some time and try to understand the logic. This is all about insertion sort. So, it will try to do the same thing. If the 2 comes here, it will try to compare it with the 4. So, it will move one position right side, again it will compare with the 5, it will move one position right side. So, the two positions will be shifted towards the right. So, that means after this one 4 5 will be shifted 2 positions right side and 2 will be inserted in the front. So, this is all about insertion sort. So, we will try to quickly run my bad. So, dot slash c line, sorry, dot slash insertion. So, you can see we are passing, we have passed 12 11 5 6 3, and you can see the sorted element after the after calling the insertion sort. So, the this is all about insertion sort. So, the finally we were trying to do is selection sort. So, selection sort is selection sort is works bit different from these two sorts. So, selection sort algorithm is like, so first it will try to take the first value. So, it will find out it will try to find out what is the minimum value in all the array, and it will replace with index 1, and again it will move to the index 2, and from all this index 2 to n it will search the minimum element, and it will find, it will try to replace that value with index 2. Similarly, after index 2 it will come to index 3. So, it will find another minimum value in all these 3 values, and it will try to replace that value with index 3 or swap this value. I mean replace in the sense swap, and finally it will come to these 2 values, and it will try to swap I mean find out the minimum value and swap. So, you can see from the start. So, initially 0, it will find out the minimum value and it will swap it with the fifth one. The set space will be here. So, second element will be 2, so it will be searched. So, third, these 3 values, it will find the minimum value as 5. So, again it will do the search on this thing. So, the whole idea is finding out the minimum value. So, first finding out the minimum value in array, replacing it with the first index. So, increment the index, again find the minimum value and swap the values with the second index, and after second index you just come to the third index. From 3 to n you try to find the minimum value and you try to replace the value. So, that is the high level understanding of selection sort. So, you can take this example 64 25 12 22 11. So, 64 25. So, after going through the first iteration, so the minimum value is 11. So, we will swap the first element with the 11th value. So, 11 will be here in the first and 64 will be last. So, again then we are ignoring the 11. So, from here we are starting. So, 25 12 22 64 is in this thing, the 12 is the minimum value. So, we are swapping the 25 with 12. So, right. So, 25 with 12, 11 12 25 22 64. So, after these two values are done, so 25 22 64. So, the minimum value is 22. So, 22 will be swapped with 25. So, again the 25 64. So, these two values are already swapped. So, the program will terminate here, and the sorting values will be done. So, this is the high level understanding of the selection sort. The fundamental difference between the bubble sort and the selection sort is, bubble sort we are doing the pairwise comparison and we are moving the biggest elements toward the last side. In the selection sort we are doing the finding the minimum element and swapping with the consequent index values in an array, so that every time the minimum value is replaced with an index. So, let us say initially 0 to 5, the 0 minimum value will be put it into the 0th index, then it will start from index 1, and whatever is the minimum value that will be swapped to the index 1. So, then it will come to index 2, and whatever is the minimum element that will be swapped to the index 3. Like that you can see the elements are sorted one by one, because first minimum value is the least minimum, then the subsequent minimum value. So, you finally you will get the sorted array. So, this is the logic for the code. So, initially for I equal to 1, I less than n, I plus plus. So, key will be initially a of I, the first element. So sorry, I am doing the, I am showing the wrong example. So, for I equal to 0, I less than n minus 1, I plus plus, and initially we are assuming that the minimum index will be 1. So, then 0 to n minus 1 and I plus 1 to n. So, I plus 1 to n means we are fetching from I plus 1 to n what is the minimum value, and we are just swapping that particular thing. So, here I have clearly said find the minimum element in the sorted array by using this logic, swap the minimum element with the first element. So, then the index will be changed and it will be iteratively doing the same thing for the remaining portion of the array as well. So, this is also the same example. So, we will try to quickly run and /selection. You can see the sorted values here. So, this is all about I would like to discuss. So, I think we will jump into the quiz part. So, let me try to share this particular specific portion of the window.
Sir, please repeat selection sort, sir.
Okay. Okay. So, who asked the question?
Sir, it's me, sir.
Okay. Puri, the thing is, let's say I will try to illustrate with this example. Let's say you have this unsorted array, unordered array. So, what the selection sort algorithm is doing is that, so it will try to start with index 1 with 64. So, it will try to keep this one aside, and it will try to find out the minimum element in this particular remaining elements. So, in this portion of arrays it will find out the minimum element which is 11. So, whatever is there in the minimum element, whatever is there as a minimum value here, it will just swap these two values. So, you can see that 11 will be swapped to here. So, then the first portion is over. Okay. So, then it will come to index 2. So, it will not do anything with, so index 1 is already swapped. So, you are not touching with the index 1. So, index 1 will be incremented here. So, so now we are here, and it will try to find out the minimum element in these three values. So, which is 12. So, 12 value will be swapped with 25 value. So, you can see that 12 and 25 and 12 got exchanged. So, now these two portion is over. So, index will be 3. So, here 3. So, what value we need to replace is by doing finding out the minimum element in this particular value. So, in both these values 22 is the minimum value. So, we are just swapping this 25 with 22. So, you can see that 22 and 25 and 64 is there. So, the fundamental idea here is that every time when you do this, you are in the first iteration you find the minimum element of the whole array and you are positioning it in the first place. In the second iteration you are trying to find out the second minimum element in the array and you are trying to swap it to the position 2. In the third iteration you are trying to find out the third minimum element and you are trying to put it in the third index. In the fourth iteration you are trying to find out the fourth minimum value and you are trying to put it in the fourth position. So, the selection sort, we are selecting the values which are minimum and we are moving it to a specific position. So, that is why it is called as selection sort. You got it?
Yes, sir.
Okay. So, time complexity of this selection sort is also big O of n square, because in the worst case it will be n times n. You need to iterate through all the array, because you can see from the code selection sort you have written one loop and again you have one loop. So, it is iterating for n times, again the second value is also iterating for n minus 1 times and you are doing n times n. So, n cross n will be n square. So, that is why time complexity is big O of n square. So, anyway we will try to start the quiz question. So, I hope everybody is understand with the 3 sorting algorithms that I have explained, right? Okay. So, let us see what is the first question. So, what is the Arshad, you can ask question.
What is the effect of time complexity on a software?
Yes. So, the time complexity is, see, the time complexity is will define how much time that this particular algorithm will take for execution. So, it will indirectly affect your computer's performance because it is taking that much amount of time. Let us say assume that, let us say for doing each comparison it will take one CPU cycle. If the time complexity is big O of n square, if you are doing if you are trying to sort an array of 10 elements, it will take 10 CPU cycles or 10 square, which is equal to 100 CPU cycles. But assume that the values in the array are 1 lakh square CPU cycles it need to perform the sorting. So, it will indirectly affect your computer's performance or CPU performance. So, that is why it is called as time complexity. The time complexity indicates that how much time that the CPU need to dedicate to your algorithm to finish the task. Got it?
Yes. And one more question. How CPU differentiate in time complexity?
No, CPU doesn't differentiate in time complexity because we became intelligent and we are trying to schedule a task. So, if you have read operating systems, so every time operating system, let us say if you try to execute a program, so it will not be executed directly onto the machine. So, it will be there, the process will be created and it will be in the queue, and the process queue will be taken out, and the particular process is allocated for a specific time. Let us say if it is in round robin fashion, it will be given a specific amount of time to execute this particular task on CPU, and then the next task will be, then the OS will preempt. The preempt means that will be holded back to the sleep state and execute another task, and after a specific time it will be taken out and again the third task will be executed. So, there are many tasks in the CPU that can be executed in parallel or that can be preempting. The operating system will preempt, that means it will take out and it will swap in, swap out. So, if you try to run the large program, so every time the whole thing will not be there in the memory. So, just for a specific amount of time the whole CPU will be allocated for you to execute the task. So, we are being an intelligent programmer, so we are trying to find out okay, let us say if I run this particular sorting algorithm, okay, it might consume this much amount of CPU cycles, so it is not an effective algorithm. If you consider the linear sets, so for just searching a single element, so we just need to iterate over all the elements in the array, which is a dump process. So, that is why they came up with the binary search. So that means we are just reducing the search space so that it will take less time when it's trying to execute on the CPU, so that your CPU cycles will not be wasted on the useless task. Got it?
Yes, yes.
Okay. So let us try to go to the quiz questions. So what is the worst case complexity of an selection sort? I think we have discussed this thing. You can answer it in the chat box. Yes, big O of n square, you guys are right. Option D is the right answer, because as we discussed. Uh, so what is the correct order of insertion sort of an array 83594? Take the pen and paper, try to solve it. So insertion sort means we learned about it. So we learned about the insertions. Okay, sorry, we learned about the insertion sort. So it is like playing cards, arranging the cards. You try to remember that and try to see which answer is right. Take the pen and paper and work on it. So otherwise you will not get the answer. What is the iteration? In what iteration? So initially it will take only one element, then it will take the second element and put it in the place where it wants. Okay, Vashini is saying that this is answer A. Okay. Okay. Okay, the answer will be A for this particular question, because initially the one particular element 3 will be taken and it will be there, and remaining all these elements, let's say first initially 8 will be there. So in the second iteration, so 3 will be given, 3 will be taken, so 3 will be put in the first place. So 3 8 5 9 4, remaining all elements will not be touched. So again the third element will be considered 8. So the third element is 5. So 5 will be coming in between 3 and 8. So 3 5 8 9 4, and 3 5 8 9 4, and the fourth value will be 9. So 3 4 5 8 9. So answer is A. Okay. So let's go to the next question. This is quite easy question, so you just need to listen to the class to answer this question. That's easy. Okay. Okay, so everybody, most of the guys are going good about this answer. So the binary search will work only the elements are in sorted order. Cool. So next, oh, this is big one. Okay. Sorry guys, I can't help you. So what code snippet is performs unordered linear search iteratively. So there is one more option. Oh, D is there. Okay. Sadananda Kumar is saying that it's A. So there is one more option. I think it's okay. D is none of the above. So you just need to look ABC. So anybody is going to answer? Okay, so let's try to, okay, Harshad is saying A, Varshini is also saying A. Okay, cool. The right answer is A because you just need to understand the logic here. So let's say in the unordered linear search, it will iterate from 0 to n, and if the array of I equal to data, so you just try to use the index equal to I, then break, come here and return the index. So this is right answer. The problem here is here index is not assigned to any value, so it will just break out and return, it will return a dummy value, and here it is like just continue, that means it will just skip that iteration, it will go through the loop again. So there is no point it is returning, so the index will be some useless value. So option D is also not right. So this is about problem 5. So option A is the right answer for the 5th question. What is the best case and the worst case complexity of the linear search? So best case means what is the best possible case? Okay, okay, most of the guys are saying D, B, D, B. Okay, the right answer is option D because the best case is like whenever you find the fetching element in the first place, so that is best case. So that is big O of 1. You just need to look into the one element, so you will get the value. So that is big O of 1. The worst case is if the even though it is ordered or unordered, if the value is there in the last value, the element which you are searching is there in the last index, you just need to go through all the indexes to search, and finally you will get the value in the last. So that is big O of n. So best is big O of 1 and the worst is big O of n. So that is about, yeah, I am expecting this to be right. So I just want everybody to answer this question. Question number 6. Take the pen, find out left what is low value, what is high value and middle value, then do the binary search. In the second iteration, they want what is the middle element in first and second iteration. So that's what they want. Read the question carefully. Very good. I'm happy. Is there any other answers? Okay, so the option A is right answer because first thing you need to say, you need to understand whenever you are doing the binary search is whether the element is sorted or not. You need to check, number 1. Number 2, here the low value is 0 and the high value is 6. So low plus high by 2 is equal to 3. So that means 91. So 91 is the middle element, and the second thing is that 91. So after 91, from 94 it will start. So from 94, so from 94 to 100 it will do the search. So 94 is there in 4th and 100 is there in 6th. 4 plus 6 by 2, that is equal to 5. That means 98 is the middle element. So 91 and 98 is the answer. That is option A. So yeah, I think it is bit tricky, but you can answer. A is a 54913. So consider the cast. So how many swappings do you need? So Based on that, each time I don't think more swapping is needed. So based on that, you just, so what is the total cost of the iteration? Element 1 has to be, Varshini is saying that it is 50. Varshini, can you unmute and tell me why it is 50?
So because in the first swapping 4 and 5 will swap
Okay, okay,
and it costs rupees 25,
okay.
and in the next one, one will be in the first place, it
Hmm.
will be get inserted, and that swap will cost 25, so 25 plus 25 50.
Yeah, you are right. So it will cost only two swaps because 45913. So if you try to, so in the first iteration 5 will be only there, and just we are putting taking the second 4. So 4 will be placed in the first place. So one swap is gone there. So 125 rupees you have spent. So another 25. So then whatever the array we have is uh, 4 5 9. 9 is already greater than 5, so we don't need to do any swapping here. Then we will come to 1. So 1 will be placed, 1 has to be placed. So it has to search 9 is less than 1. No, so uh, 9 is less than 4, 9 is less than 5, 1 is less than 9, 1 is less than 5, 1 is less than 4. So 1 will come here and you need to swap for the second time. So you cost two swaps, so it will be 50 rupees. You got it? You just need to learn about the insertion sort, understand insertion sort to calculate this value. You are right, Varshini. Good. So find
Sir, then we have to swipe 3 also, na, sir, the last element.
no by the time, so that's what the confusion happens. So by the time you take the one, you don't need to take there is there we don't pick 3, so it will be picking randomly one by one, right? So when you take let us assume you have 5 these card numbers as uh, so these card numbers as playing cards. So let's say you have 5 in the first place, you kept your 5 in your left hand. So you take 4, so you keep 4 before the 5, so one swap happens. So next one is 9, so you just keep the next one here. Next one you have to take 1, and you need to, okay, compare 9, it is 1 is less than 9, 5 4, so you need to keep here. So they have specifically asked, so what is the total cost of the insertion sort when the element 1 reaches to the first position? It will reach the first position in the third iteration itself. We don't need to look for the 3. Got it?
Okay.
Okay. So that is about. So this is pre-increment and post-increment question. So this is a bit tricky, and I want you to answer it correctly. Take some time, 1 minute, sit back, relax, and try to understand, because they are doing some gimmicks here. Four. Arshad, can you unmute and tell me why it is 4 4?
Yeah,
Yeah, you explain me why it is 1 4 4.
because when we choose 2, its pre-incremented value of 2 is 3, and we post increment 3, it is equal to 4, and we are printing A. So firstly A get the 4, and then we are post incrementing value of 3.
Cool, you got it right. So answer is 4 4. So I think for this I have an example as well, but I don't think you need the example. But for the people who's not able to get that thing, I will show you. Let us try to understand. So in the same code, I am trying to print the values. Um, so initially AR of 1 equal to pre-increment. So can you mute Arshad? Okay. So I have used a print statement to print the value of ARR1. So ARR1 equal to plus plus of ARR1. So 0 1, 0 1 is 2. So we are pre-incrementing. So the 2 value will be incremented before and it is assigned to ARR1. So 3. So the value of ARR1 here is 3. Then we are using ARR1 A equal to ARR1 plus plus. So this is post increment. So the 3 value will be assigned to A and it will ARR1 value will be 4. So we have 1 4 3 4 5 and A value will be 3. Then we are assigning ARR1 equal to A plus plus. So A plus plus means, so A value is 3. So ARR of 3 means 0 1 2 3. So 4. So ARR1 equal to 4. So after 4 the post increment. So that means A plus plus means A will be incremented 1. So 3 will be 1. So both ARR1 and A value will be 4. So just for the sake I will execute dot slash E1. You can see by the, when we complete the step 1, the ARR1 value will be 3. Step 2, the ARR1 value will be 4 and A value will be 3 as we expected. Then in the step 3 in the sense after doing this particular operation, so ARR1 value will be 4 and A value will be 4. So finally we will get 4. So I think that's all for today's class. So we try to learn about some fundamental searching and sorting algorithms and what is the use cases of macros and the real time, and we try to look into the bubble sort, insertion sort and selection sort. So you try to read more about the asymptotic notations and try to learn about different sorting algorithms as well, and sit back and look. So you can go for Geeks or some other website where they can give a detailed elaborated explanation about all these sorting techniques. There are various other sorts. So if you are very much interested in data structures and algorithms, you can try to understand this one in detail in all those by going through all those links. So I think that's all for today's class. I will stop here. If you have any questions, I will take it now. Otherwise, we will meet in the next class. It's okay, Arshad, no issues. So, seems like nobody, is anybody having any question? Okay, seems like there is no question. So that's all for today's class. Have a great evening and hopefully we will see in the next class in the upcoming Tuesday. Thank you guys. Good night.
Thank you.
Thank you everyone. Bye.